Hey guys, this is Miss Hart-Townsley, and I just wanted to, I know I've given you a little bit of a tutorial over these heredity patterns, but I'm still getting a lot of students miss this type of problem, so I just pulled up a quiz, and so this is a random question, and some of you might actually get this question on your quiz when you take the 3.04 quiz, but I want you to notice the genotypes of the parents, okay? What I see a lot of people doing is giving me, and I'm just going to go ahead and write this for you, is a dihybrid cross. Okay, and a dihybrid cross we know is a 4x4 grid, and it is a result of both parents being hybrid for two traits. That's how we get the word dihybrid cross. Okay, but if we look at this question, so question number 10 in the background here, it says that in one type of plant, we've got orange petals, we've got yellow petals. I'm going to scoot this kind of out of the way so we can see. And we've got tall stems and short stems. It says to complete a dihybrid cross for parents with these genotypes. Okay, and so this is a mistake. Okay, this word right here should not be there because these organisms are not dihybrids. Okay, and so if I could change that word, I would, but I can't. And so you have to look at it and look at the possible parent genotypes. Okay, so for example, my first parent, we're just going to call that the female. Okay, so my first parent, and guys, I'm looking right here. Okay, I see that her genotype is homozygous dominant for the flower color or the petal color, and she's a hybrid for stem height or stem length. Okay, if I look at the other parent, we'll call that the male. He's going to be a hybrid for both. So he's going to be a hybrid for flower petal color and a hybrid for the stem length. Okay, so if I look at their possible gametes, all right, the only gametes this female can donate in her egg is going to be a dominant allele for flower petal color, and she could give a dominant for height, or a dominant for flower petal color and a recessive for height. Okay, whereas if we look at the male's possible gametes, he could have dominant for both, dominant for one, dominant for the other and recessive, or recessive for both. Okay, so what that ends up being is actually a 2x4 cross, not a 4x4. And so when I set it up, and I'll just go over here and try to set it up nice and neat for you guys. This heart doesn't have a ruler. Hopefully you can do it a little bit neater. I'm going to go ahead and put the maternal gametes on the top. And so I know that she can give a dominant for both, or a dominant for one and a recessive. And then I'll go ahead and put the 4 possibilities for the male over here on the other side. Okay, when I go ahead and do this cross, the rule is keep the letters the same, in the same order, and always do capitals first. And so in this first box, notice that I'm dominant, homozygous dominant for both. I'm going to go ahead and go across. I've got 2 dominants and a heterozygote. I've got 2 dominants and a heterozygote. 2 dominants, homozygous recessive, heterozygote, homozygous dominant, heterozygote, homozygous, or heterozygote, 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 homozygous recessive. All right, so those are my possible gene or genotype outcomes. All right, and so I kind of have to, I'm going to list those. If you draw your Punnett square, I will be able to see where it says on number 2, list the likelihood of each possible offspring genotype. Okay, I'm going to see that you've got all the genotypes. Now it's your job to tell me what percent. Okay, so there's only 4 possible genotypes, so I'm going to write them down here. I know that I can be dominant for both, because I see that one. I know that I can be dominant for color, heterozygote. I know that I can be, so that takes care of those 2. I could be dominant for both, homozygous recessive. I could be a heterozygote and dominant for height, or a heterozygote for both. And I could be a heterozygote and a homozygous recessive. So I have 6 possible genotypes. Those are my 6. Okay, and it's out of 8. And so if I look at this first genotype right here, I know that this occurs out of 8 possibilities. I can only be dominant for both once. So I'm going to put 1 out of 8. Okay, when I look at dominant and heterozygote, actually, and I'm going to cross this out because I've already got that one. Okay, I can see that I can be dominant for the color and heterozygote 2 out of 8 times. Okay, dominant for flower color and homozygous recessive, 1 out of 8. Okay, heterozygote and dominant, 1 out of 8. And heterozygote for both is 2 out of 8. And then heterozygote and homozygous recessive is 1 out of 8. If I were to add up all those numbers, that would equal 8, and that's what we're looking for in question number 2. Okay, now question number 3 is also looking for a ratio, but it's a phenotype. Okay, so if these right here are the genotypes, now I want to see what these guys look like. Okay, and so if I go to the parent up here, I know that O, this capital O, means orange, and the little o means yellow. The capital T means tall, and the little t means short. And so now I'm going to look at the possible genotypes. So I'm back over here, and I know that I can be, and I'm just going to write them over here, so I could be orange and tall, because I see that in there. I also see that I can, well, let's just put them all down there. So I could be orange and tall, I could be orange and short, I could be yellow and tall, or I could be yellow and short. Let's see how often these happen. Now remember, this is out of 8. And so how many times out of 8 am I going to be orange and tall? So I'm going to go and I'm going to cross out over here again. So 1, 2, 3, 4, 5, 6. So 6 out of 8 times I'm going to be orange and tall. All right, so I have a 75% chance, if we wanted to convert that to a percentage or likelihood, I could say 75% chance that I'm going to be orange and tall, which leaves me to, let's see, we've got orange and short. So I've got 1, 2, oh, that's all I have. And then 2 out of 8, I could be orange and short. So only 25% chance of being orange and short. Notice how there is absolutely no chance of being yellow and tall, and no chance of being yellow and short. And it has to do with this parent only donating a dominant allele. All right, so she is not a hybrid, she's a true breeder. So no matter what, she's going to donate that dominant allele, therefore her offspring will show that phenotype. Guys, like I said, we can convert these into percentages if it's needed, otherwise you can write it like this. And so this is how to solve a cross that's not a dihybrid. You just have to assign the gametes, so that was our first step, make the cross or do the Punnett square, that's the second step, and then evaluate the genotypes and phenotypes, which is our third step. Okay, and so hopefully that helps a little bit, guys. If you have any other questions, let me know. I'll talk to you guys later. Bye.